So, hi everybody. My name is Andrii Neronov, and I will show something about a platform that is called Multi-Messenger Online Data Analysis. We are developing it with a group of people. It's a common project between Astrophysics and Cosmology Laboratory here in Paris, but also University of Geneva, EPFL in Lausanne, and Kiev Academic University. So this is mostly not about transients, but it can serve some, I don't know, post-analysis for transients. It is complementary. And our motivation was a bit different. Yeah, let's say we are talking here about this findable, accessible, interoperable, and reusable. And there is a big trend. Collaborations tend to make their data sets public. This is some examples. I don't know. There are photons as neutrinos with ice cube, even ultra high energy cosmic rays with Pierre Auger. So here we are talking about data set. Well, this is list of events. Then this is of course findable and accessible, since it is by definition public, right? But is it really reusable? It is not reusable if there is no software to analyze the data. Then if we look a little bit further, there are here and there directly related or not directly related public software sets that can be used to analyze one or the other data set. Well, my own experience, for example, with IceCube, I looked at IceCube data. At the beginning, I had to write myself, well, with the help of some people around me, likelihood analysis for that data, because they really didn't say what is the way to analyze the data. Later on, I learned that, say, there is this SkyLLH framework, which is one of the frameworks to analyze IceCube data. But again, this is a software package. So in the software package, there are many, I don't know, peculiarities. It's not obvious how to walk yourself through to reproduce at least the result that is reported in the 10-year IceCube paper. So it's not obvious. There are no workflows offered that are really usable. So our idea was to sort of do maybe a catalog of these workflows that we understood once and memorize them somehow. And well, once we memorize this, well, I don't forget how it worked 1 year ago with IceCube data analysis, but I can share this and everybody can reuse this because everything is public. So the idea was to do some service or a set of services that would memorize these data analysis workflows and do sort of one-click results. After all, in astronomy, we are always interested in the same thing. We want images, we want spectra, and we want light curves. So at least for these three basic data products, we can do something that is very standardized, and really you just change a bunch of parameters and it works. Well, maybe I will use this IceCube as an example. So the data set is there. An example of well, analysis software kit is there. So it is a matter of just implementing this as a service. That's what we do with this multi-messenger online data analysis. IceCube is one example. It is a tab in this front end there. I have animations which are not completely appropriate. Yeah. So just, well, it is obvious that this complements this findable, accessible. It makes the data somehow interoperable and really reusable. For IceCube, there is a direct benefit. Well, how it works. So just, well, there are some parameters to define for IceCube. They worked by seasons. So we can, well, for example, extract something about neutrino sources per year, not the whole 10-year data set. Then, well, there are other parameters. Of course, we can do it for any location on the sky, not only for the sources that are listed in IceCube paper. That's immediate benefit. For example, of course, I took a source that people know, 1068, and GC 1068 is the strongest neutrino source on the sky. I enter its parameters, I tell what I want. It gives me the spectrum, the 68% confidence band, or an upper bound if the 90% upper bound if the source is not detected. In this SkyLLH, there is a tutorial that tells you how to do this in this or other case for whatever statistical assumptions you want. So once it is done, I don't need any more to worry about this. Next time I come, I press the button and I get, for example, an upper limit on a source that is not detected by IceCube, and it is not listed. It is not their pre-selected list source, right? So, but I can do it for any location on sky. For any gamma ray burst, I can extract now neutrino upper limit. If it is useful, I don't know, but well, something in this sense. So this is accessible from that front end, MMODA.io, but also if it is possible to get it right from your laptop, if well, this ODA API package is installed, so it can be a request to the service that runs somewhere. It runs sort of on whatever HPC. It doesn't matter because from your laptop you see it as locally executed. Yeah. So then, yeah. So this is let's say we started to do this instrument by instrument, but then the next idea, okay, I learned something for one instrument, somebody else learned something for the other instrument. Somebody else is doing this for life for some specific telescope all the life, right? So why don't people share those workflows? You can always wrap a workflow in a Python, I don't know, script notebook, something like this. So it is enough often to share this Python script if you make it understandable for everybody. So how to make it understandable? As an example, we tend to use a platform that is provided by this École Polytechnique Fédérale in Lausanne called RencoLab. It has Jupyter Lab integrated with GitLab, so that's a convenient way to develop things. Then how it works, for example, for IceCube and for any of those workflows that we have, services that we have there, we put some notebook in a domain in RencoLab called Astronomy MMODA. Then once this repository with this notebook is tagged that it is supposed to be a live workflow, means visible as a service on MMODA platform, there is a bot working on this repository looking for notebooks that are properly formatted. As soon as it finds one, it tries to create a service with a front end and API. So how would the bot understand what I'm doing in this notebook? There are just two basic things that it needs to understand. What are the inputs? What are the outputs? So for the inputs, we designate one cell in the notebook that is called inputs or parameters. Yeah. And then even for if you just give parameters, the service would just show these parameters on the front end as it is, not verifying anything. But there is also a way to do better. We have created some ontology of astrophysical workflows. If you enter sky coordinates, and you tell that these are sky coordinates according to this ontology, after a hash, you tell that this is right ascension or this is declination. The bot will also try to verify if the formatting is right and visualize it as it is. It can also verify if this is within limits that are reasonable and stuff like this. So with a bit of help, the service becomes more user-friendly. The same for the outputs. If you tell that it's a fits file, it will sort of give you this fits file or AstroPy table, or well, if it is an image, yeah, if it will format the image and visualize it appropriately. So then, well, this is available to everybody. Everybody is welcome to try your favorite telescope. We will be grateful if people start adding telescopes. So there is a guide. We try to maintain it as detailed as possible, but really the process is very simple. So then it appears all the time. Yeah. And actually, we are not alone going this way. We joined another project around some other platform like this called Galaxy. And once we know, well, we learned how to do this for our MMODA, we can let the same bot interpret this notebook and make it available as a service on this other platform. We add just another tag, so the bot will know that he should try to produce a service for this platform, and it works. So this is on occasion a project, it's a Horizon Europe project related to European Open Science Cloud. It's called Euroscience Gateway. So originally it was a platform for online data analysis created by bioinformatics community. But, well, surprisingly, bioinformatics workflows are not different from astrophysical workflows. So they start to get some more and more workflows from astronomers, from us, using, well, this is this bot that creates also astronomical data analysis services on another platform. So the approach seems to be convenient and quite universal.